Okay, this is Geometry Lesson 7, Part 2, and we're going to be doing the Build Your Skills 5, 6, and 7. Okay, a transmission tower is being built to provide power to a new residential subdivision. On the tower, braces A to B, so from here to here, C to D, from there to there, and E to F must all be parallel to the ground. What adjustment needs to be made to angle DCF? So if you trace from D to C to F, that is this angle. What adjustment needs to be made to angle DCF for CD, this bar here, to be parallel to the ground? The adjustments will be made by raising or lowering CD at point D. So undo this part and lift it up or down. Okay, so it's hard to see it right away. So I'm just going to redraw C to D and E to F. And I'm going to take the cross piece and cut through, but I'm going to leave some room. So here's where C would be attached, and this is F. The reason I'm doing that is because you can't really see the fact that if these two C to D and E to F are parallel, you can't see that you have to view it as a transversal through two parallel lines. So I'm extending this cross member here through so that we can see. Okay, and I'll just put in some um, dotted lines to kind of show where the side pieces would be. So they would kind of be like that. Okay, and then like that. Now it's not the best drawing, but it'll work. Okay, so 43 degrees is right here. Okay, and we know from transversals and parallel lines, this angle right here also has to be 43 degrees if these two bars are going to be parallel. So we need to bump 41 up to 43. So we'd have to take this arm, undo it, and lift it up and make it 43. And then the two bars will be parallel. Okay, so in words, the angle of 41 degrees needs to be raised to an angle of 43 degrees. Raise the bar at point D. Okay, because if we swing this up, this angle will increase, and that's what we want. Okay, what will be the measure of angle CAB and Y? So CAB, if we trace from C to A to B, that's this one. And the question is, what is that angle? Now, that angle should be the same as this one. From here all the way to there. But we've adjusted this to 43 now. So 51 plus 43 degrees is 94. And then therefore that same angle, okay, so we can take it, move it up, should be the same. Okay, these are identical trapezoids. And the reason is one's just smaller in size. Okay, so trapezoid, I'm talking about this, right? So this has to be 94 on the trapezoid. This is just a smaller version of the one below. Okay. And if this is probably an isosceles trapezoid, so these two are parallel. Okay. If that is the case, then this angle is also equal to this one. And this angle would be equal to this one. Now, why can we say that this one is the exact same as the one below? The bar from E to A is on the same angle for both trapezoids. So because of that, this is just a smaller version of this one. It would also be 94 degrees. The A to E post is on the same angle for each section. Okay, so reason being again, from E to A is on the same angle for both trapezoids. They both have parallel bars. So with this same angle, you're going to create the same internal angles as the one below. It's just spread. The bottom one is just spread further apart. That's all it is. Okay? As in the sides are just further apart, but that's the only thing. Okay. What type of quadrilateral is A, B, F, E? So the entire thing. So if we just scroll up really quick, they're just talking this entire frame here. That is a giant trapezoid itself. Okay. So AB, the bar A to B, and the bar E to F are parallel. A to E and BF are not parallel. So those are the sidebars. But they are the same length. This is, so if you have one set of parallel lines and two sides that are the same length, this is an isosceles trapezoid. Okay. Number 6. Leslie is building a planter for her front porch. Okay, so it's kind of like a bin. The planter is a trapezoidal prism. So you can see the trapezoid here, but it's also got these other pieces that's giving it volume. Okay, so this is area, and then you got the length, and it's going to create a volume. At what angle does she need to cut angle A? Okay, and we got some measurements there. And if I just pull that piece out of there and redraw it, this is a 90. That's angle A. 30. And it says the top is 2.5. Okay, so if we have a right angle triangle, we could use um, SOHCAHTOA. So we got opposite, straight across. This is your hypotenuse, but we don't have a value for it. And then the last one remaining is adjacent. So if we have opposite and adjacent, we should use tan. So opposite over adjacent. So tan theta 30 over 2.5. And then from here, you have to do second function, tan, in your calculator. So it should come up 10 to the -1. Put the fraction in the brackets. So 30 divided by 2.5. Close the brackets. Make sure your calculator is in degree mode. And the angle A will come out to 85.2 degrees. Now, B, how much soil in centimeters cubed, so that's volume, as soon as you see cubed, can the planter hold? Okay, so a max amount of volume. Now, it's not usually well known the volume for a trapezoid equation. However, we know the volume, or sorry, the area of a trapezoid, which would be the front piece right here. We could get the area of this. That's 2 dimensions, but we need the third dimension, which is the length going back or the depth. Okay, so how could we create a volume equation? So if we just look at a standard square, okay, and the old saying is length times width, but we're going to be going 3D. So this is height and width, and that's how you would get the area, right? But as soon as we add some depth to a square, we've added a third dimension, which now is volume. So now we have a length, okay? And we know from just grade 9, grade 8, grade 7, the volume of a cube is length times width times height. So here's our area. And to get the volume, we would just add on length. Now you can use an uppercase L, it doesn't matter. And you're going to go, but that's not in the same order as the old saying, length times width times height. The order that you multiply in doesn't matter. Okay, 8 times 7 is 56. 7 times 8 is 56. The order doesn't matter. So all we did was we took our area and multiplied on the third dimension. So what we should do is step 1, find the area of the front part, the trapezoid, and then step 2, our volume is going to be equal to the area times the length, which is the depth of the planter going back, which should be 1.5. Now, it says in centimeters cubed, so we got to be very careful here because some of this is in centimeters, this part is in meters. If you're not in the same unit, you will mess it up. So we need to convert this to centimeters, which would be 1,500. Okay? Oh, sorry, 1.5. So 150. Okay? So we just got to be careful there. That might have been where you went wrong in the actual crunching of the numbers. Okay. So we got 1/2 A is the length of the parallel sides, and so is B. And it doesn't matter which one you label. So this could be A, this could be B. You could switch them. We're just adding them together. The order there doesn't matter. So I think I went 40, 35, and the height is 30 right here. Okay. So add that in. And this will get us the area. So, and you got to make sure you crunch this all in the right order. This is turns into 75 and then 30. Okay, now you can multiply them all. And you end up with 1125 centimeters squared because it's area. Now, if we go over to volume, we're going to take our area and multiply it by 150 centimeters because that's the length and we should get the entire volume of the planter. So 1125 times 150 comes out to 168,750 cubic centimeters. That's your volume. Okay. Seven. Ian is sewing a kite that he plans to take to the annual Windscape Kite Festival in Swift Current. And here it is. Here's some measurements. It says, what are the measures of angle BCE? So draw from B to C to E. It's that angle. Remember, it's always the middle one. So angle C. CBE. CBE. That one right there. Okay. So that's what that's talking about. So you just trace in order. And then it'll always be over the third letter. Okay. So looking at this, we got some measurements to help us out here. If it's 80 from A to C, that would mean the bottom of each triangle is 40, and then it's 40 tall. Okay, and we got a right angle. So I can just draw that away here if you need. So B, C, right angle. This is 40, 40, and we got to find both angles. Okay. So looking at this, I'm just going to solve for the first one right here, angle C, and this would be opposite and adjacent. Now, if you chose to do angle B first, 40 would be opposite, and this one would be adjacent. But lucky for you, the numbers are the same. So we're going to be using tan, opposite, adjacent. Okay, so angle BCE, we're going to go tan theta 40 over 40. Second function tan 40 divided by 40 is 1. And we end up with 45 degrees. Okay. So now we know that that angle is 45. So I can write in red here, 45. Now we can use a bit of logic here too. If we know this is 90 and 45, we don't have to do this all over again. We can just subtract the two angles that we know from 180 to get the last angle. So angle CBE, 180 minus 90 minus 45. It is also 45. And then it asks what kind of triangle is BEC. So this one right here. Okay, well, first of all, by angle, it's a right angle. And then by side length, if it has two equal sides, it's isosceles. So just to review, 3 equal sides would have been equilateral. Okay. 2 equal sides is isosceles. None of the sides are equal. Scalene. So we have isosceles. Okay. Next one here. What are the measures of angle EAD and ECD? Okay. E to A to D. So this angle. And then it says ECD. This one. So those should be the same. So we just got to solve one of them. Okay, 70 tall, 40 at the top, because here's the 70. So I know this is 70, I know this is 40, and I know it's a right angle. Perfect. Okay, I'm just going to bring it down here and draw it so you can see it as I do the work. So this is right angle, this is 40, 70, and we're looking for this angle here. Okay, so straight across from the angle, the unknown angle is opposite. This is our hypotenuse. We don't have a number for it. And this is our leftover adjacent. So we are using tan again. So tan theta, opposite is 70 over 40. So second function tan, and this comes out to 60.3 degrees. So angle EAD and angle ECD equals 60.3 because they're equal. And then our last question. What are the measures of angle BCD and BAD? Okay. So what they mean is B, A, C, and D. So B, C, D, B to C to D, this one, and B to A to D, this one. Okay. Now, we already know that half of this, we just figured it out, is 60.3. Okay. And we know these ones up here. We figured out that these are 45, which would mean this side is also 45. Okay. So what we can do here is if we want to figure out A, the whole thing, we need this little sliver chunk right there. Okay. So I'm just going to focus on B and A. Because once we get one of those, we'll be good to go. Okay. So we know this is 45. This is 90, right? So we should be able to figure out that last piece. So 180 minus 90 minus 45, which is 45. And that would have been the same. So we really didn't have to do this work again because we already solved for it up here. Right? We figured out that this was also 45. So therefore this is 45. Okay. And I'm just showing you again where it's all coming from. So then therefore that angle equal 45 plus 60.3. So our answer is 105.3 degrees for both. Now it says D. How much in color, or how much of each color of material, gray and white, is needed to make the kite in centimeters squared? So that's area. That's what that means. And if we look up here, there's the gray, there's the white, white, and gray. Okay, so what I'm going to do is just redraw it really quickly. It's a bit off. Okay, so this was gray, white, white, and gray. Now, what I'm going to do is calculate the area of each big triangle. So I'm going to get the area. I'm going to call it area 1. and it will be the top chunk. Okay. And from some of the measurements above, the height of this thing is 40 and it is 80 across from here to here and 40 tall. That is enough to get the area for the whole thing. So area 1, base times height divided by 2. So we got 40. Sorry, base is 80. It doesn't really matter though, but I'll just do it to match the equation. Base is 80 times 40 divided by 2. I got 1600 centimeters squared. Okay. And then area 2. So we got white and gray. And it's just a triangle upside down, so we can still use the same equation. It's 70 and 80. So then A2 base times height divided by 2. The second area is 2800. Now, for the white and the gray. So area 1, if we take that and divide it by 2, because we got to cut the colors in half, 800 centimeters squared for each color. And then area 2, it's perfectly in half. So take 2800 and divide it. So that'd be 1400 each, right? And then, so total, each color needs 2200 centimeters squared. I just added them up. The other thing we could have done, and you probably recognized it, is we could have just added the whole of the total area up and divided by 2 because it's in equal parts, right? Because you got a gray and a gray, white, white. They add up to the same amount, so you just get the total area. So add up A1 and A2 and then divide it by 2. You'll still come out to the same answer. Okay, that is the end of geometry, lesson 7, part 2.